1%. That's how much of the work a working demo represents, according to the co CEO of Waymo. 1% at best. The other 99% is the gap where AI agent startups are dying right now. And this weekend, on the Y Combinator stage, the man who spent 17 years crossing that gap, from a demo in 2010 to 500,000 paid driverless rides every single week, laid out the playbook for crossing it. By the end of this video, you'll have all 7 lessons translated for AI builders. The exponential ladder of nines, the 3AIS. He says you must build instead of one, and the single asset he calls a strategic moat, because your model, in his words, is table stakes. We watched all 49 minutes and fact checked every number. Here is the sentence everything hangs on.
Frustrating, sometimes soul-crushing difference between a demo and a real product. And a working demo is 1% at best of the work that you have to do. The many nines of performance, the many nines of reliability that follow, that's where the real work happens.
Quick context, because the source matters. That's Dmitri Dolgov. He was a founding engineer on Google's self-driving car project back in 2009, the moonshot that became Waymo. And today, he runs the company as co-CEO, fresh off a $16 billion round that values Waymo at $126 billion. This is the same Y Combinator startup school stage we've been mining all month. Jensen Huang, Sam Altman, Alexander Wang, the creator of Claude Code. Every breakdown is linked below, and the full 49-minute talk is too. Before the lessons, listen to what his agent is doing every week, right now, in the physical world.
Happening daily across our fleet. Today, the Waymo driver is serving around 500 trips per week and driving over 4 million fully autonomous miles every week in 15 cities across the United States. Just for comparison, that's over 300 years every week of an average American driver per year. And the Waymo driver is accomplishing that with a superhuman safety record.
Moment 1. If you're building anything with AI right now, this story is about you. Because Waymo hit the exact moment you're living today. The demo that works, 16 years ago. Here's what happened next.
And if you're a founder in the room, chances are you are focused on getting that first prototype, that first demo off the ground. And when you hit that first version of a system that works, that first 90%, when the demo actually works, it feels incredible. You feel like you solved it, the sky's the limit, you're extrapolating forward. And in our world, we hit that first milestone, that first 90%, back around 2010. So when this project started in 2009, before we started building the system, we set a couple of pretty ambitious goals for ourselves. One was to drive 100,000 miles in autonomous mode. The second goal was to drive 10 routes. Each one was 100 miles long, chosen to cover a wide variety of conditions across the Bay Area. And we had to do each one from beginning to end without a human intervention. We had at the time a team of about a dozen engineers, and we accomplished both of these goals in about a year and a half. And keep in mind, this was well before any of the AI breakthroughs, before ConvNets, before transformers, before BLMs, before any of the stuff that we talk about today. And yet, we got it done. And kind of by demo standards, autonomous driving was solved in 2010. Right? We handled everything. We could drive during the day, during the night. We handled traffic, pedestrians, cyclists, traffic lights, construction zones, on freeways, on surface streets. So we were, quote unquote, capability complete. And at the time, we felt like we're on top of the world. But then we quickly ran, as we started building towards the product, we quickly ran into a brutal reality that there's a massive difference between doing something once, or driving 10 routes once, and building a scalable service with nobody behind the wheel. It took us about 10 more years to begin providing a service, and then 5 more years to scale to 500,000 trips per week. So the demo took 18 months, the product took about 15 years. But now we're scaling exponentially. To date, we've served well over 20 million fully autonomous trips, and we've driven well over 200 million fully autonomous miles. And we have rider-only vehicles operating in 15 cities across the United States. And we're scaling exponentially. It took us 15 years to get to that first 100 million miles, and about 7 months to drive the next 100 million. It took us about 8 years to go from the time when we started our initial rider-only operation to the time when we were serving riders in 4 cities. Earlier this year, we launched 4 cities in just 1 day.
Run the ratio back. A dozen engineers, 10 routes of 100 miles each, driven start to finish with no human touching the wheel in 18 months, before convolutional networks, before transformers, before any of the AI we talk about today existed. By demo standards, self-driving was solved in 2010. Then the demo took 18 months, and the product took 15 years. That is what 1% looks like when someone actually lives it. And if you shipped an agent demo this weekend and you're already extrapolating to a company, you are standing exactly where they stood in 2010. The sky was not the limit. The long tail was waiting. And before you file those numbers under conference stock hype, we checked every one of them against public data, and this almost never happens. They all hold. 500,000 paid rides a week, confirmed by Waymo's July announcement. 200 million miles, with the second 100 million in 7 months. The dates check out exactly. 4 cities in 1 day: San Diego, Las Vegas, Tampa, and Denver, July 8. And the 17x safety claim matches the peer reviewed data they publish. 94% fewer serious injury crashes over 220 million miles. 1 in 17 is 6%. His own slide is backed by his own audited data. Remember that for lesson 7. Moment 2. Why does the last stretch take 15 years? Because reliability is not a line, it's a ladder. And for an agent that acts in the real world, the stakes on that ladder are not measured in tokens.
First, there is the cost of error gaps. You have a language model or a chatbot or a co-pilot and it makes a mistake, usually it costs you a retry. In the physical world, the cost of a mistake can be measured in human lives, not tokens. There's simply not an undo and a retry button. So why does bridging that gap from demo to product take so long? Well, because there's this harsh engineering reality that you can't really cheat, that reliability and performance lives on this exponential ladder of nines. So getting to that first 90% or 99%, that's the easy part. But then every next 9 that you want to add, that takes about 10 times more effort. So you need to know upfront exactly how many 9s your product actually needs. So demo might need 1 9, an assist product or co-pilot might need a few, but a fully autonomous AI agent that we're going to be putting out in the physical world that engages with the public, with kids running around, that needs a whole stack of them. And at scale, the long tail is the problem space, is your entire problem statement. When you drive millions of miles per week, a rare event that might happen once in a million miles, that just becomes your daily reality. And
the exponential ladder of 9s. 90% reliability is 1 9. That's a demo. 99 is a co-pilot with a human catching the misses. Every 9 after that costs 10 times the effort of the one before. And an autonomous agent, one that sends the emails, commits the code, moves the money with nobody watching, needs a stack of them. Now translate the second half. When your agent runs 1,000 tasks a week, the freak edge case that shows up once in 1,000 runs is now happening every single day. At scale, The long tail stops being a cleanup item. The long tail is the entire job. So steal the question. How many nines does your product actually need? Your block drafting bot needs 2. Your payments agent needs more than your demo has. Moment 3. This is the machine that manufactures AI hype cycles. And it explains your entire feed, wall to wall, spectacular agent demos, and almost no products you can actually buy.
So what that actually means is that in this space, it's incredibly easy to get started, but it can be excruciatingly difficult to get to the real product. And that effect is only amplified with every wave of technological breakthroughs. And that naturally leads to hype cycles. So every AI breakthrough, from deep learning to quantum nets to transformers, VLMs, you name it, it makes it that much easier to get started. Your demos, your prototypes, they get 100 times easier. But the tail, that's where the hard problems are, that moves much less. It moves, but the effect is muted. And that's why every hype cycle produces a wave of absolutely spectacular demos and very few real products. And the recurring mistake of every cycle is spending on the demo what you should be saving for the nines. Now, this being a startup school, the last thing I want to do is throw too much cold water on the magic and the excitement of those early days. This time is absolutely magical. It's amazing. Cherish it, leverage it. But the key is to remain honest about the product that you're building, the number of nines and performance and reliability that that product demands, and not cutting corners to get there. Otherwise, you might be in for a pretty rude awakening later. So count your nines before you count your demo views.
Every breakthrough makes the demo 100 times easier and barely moves the tail. Deep learning did it, transformers did it, and the agent frameworks are doing it right now. The distance from idea to jaw dropping demo has never been shorter, and the distance from demo to product barely changed. That asymmetry is the hype cycle. It's why the graveyard is full of companies that spent on the demo what they should have saved for the nines. And notice, he isn't anti demo. He calls those early days magical. Cherish it, leverage it. Just stop lying to yourself about which one you're building. Count your nines before you count your demo views may be the most useful sentence said on any stage this year. If this video is useful, hit subscribe because it's free. And if you want to back the work hit, join here or the supporter button on Facebook. Now, the lesson that changes how you architect an agent. Moment 4. This one is for everyone who thinks a robotaxi has nothing to do with language models. Waymo's co-CEO just told you his car is having a conversation.
Making and planning, turns out the task of driving is not that dissimilar from the task of modeling language because of the social aspects of driving. You're kind of having a conversation with other dynamic actors in the world, but you're doing that in the space, kind of body language of your agent, your car, as opposed to just the language of words. And you operate in sequences, and local continuity matters, but so does global context. Our latest core technology. And the heart of it is the Waymo Foundation model. Now, the Waymo Foundation model is a multimodal world action language model. It's kind of a mouthful, so let me unpack the ingredients. It's a multimodal model because it is able to process these multimodal sensor inputs, cameras, lidars, and radar. It's a world model because it inherently understands how the world works, the physics, the dynamics, as well as the social and semantic aspect of it. It's an action model because we are not just passively observing how the world evolves. We're an active participant. So the model needs to understand the effects of the actions of our agent on the world and be able to tell the good ones from bad ones. And finally, it's aligned with language. And that allows us to unlock general world knowledge from visual language models. And that's incredibly useful in the long tail of rare semantic situations. It uses a system 1, system 2, think fast, think slow architecture. And it leverages the general world knowledge of VLMs for efficient learning of semantic tasks. So let's dive deeper. First, the think fast path. That part fuses the raw data from our cameras, our lidars, our radars, and that allows for split-second safety-critical decisions. So you can think of it as kind of your driving instincts. This is what allows the car to brake instantly if, let's say, a pedestrian runs into the road or a cyclist that's nearby swerves into your path. This is like the, if you will, the lizard brain of your agent that deals with a lot of geometric tasks and can react in milliseconds.
Catch the architecture, because the most mature physical AI on Earth converged on the pattern agent builders are rediscovering weekly. One high capacity foundation model, multimodal world action aligned with language, so it can borrow general world knowledge for the rare weird cases. And at runtime, think fast and think slow. A lizard brain that reacts in milliseconds, and a slower reasoning path that understands the car on fire and reroutes. If you're routing between a cheap fast model for the routine 95% and a reasoning model for the calls that actually matter, congratulations. You and Waymo landed on the same answer. That's not a coincidence. That's what the nines force you into. Moment 5. Here's the question most agent builders haven't seriously confronted. Where does your agent get to fail safely? His answer: the simulator is not tooling. It's a second AI, as hard to build as the first one.
So a real simulator is how you do that. And a real simulator isn't just some lightweight tooling that sits next to your AI. It is a big AI model in of itself. And the problem of building a good realistic simulator is just as hard as building the agent itself. So the AI behind the simulator really needs to understand how the world works, the physics, the semantics, the traffic, the weather, and so on and so forth. And the quality of that simulator has to be high enough so that it doesn't only look good, but it's sufficient to train and evaluate with high confidence an agent that you're going to be putting in the world in a safety critical environment. So in other words, you have to build a highly accurate generative world model in purely synthetic, rare scenarios that we've never seen in the real world. So what you're seeing here is not just a generated video, it's a full generative simulation of the Waymo driver in operating closed loop. So here we're simulating what would happen if it came across a car that was stopped in a lane on the freeway. And you can go further than that. Here's a plane that's landing on a freeway in front of us. Or you can simulate an elephant on the loose walking through the intersection. Snow on the Golden Gate Bridge. Or a dinosaur walking around. So the lesson here is that closed loop simulation is absolutely required for evaluation and is extremely valuable for training of your physical AI agents.
A plane landing on the freeway, an elephant in the intersection, a dinosaur hallucinated on purpose in closed loop, so the agent can be trained and graded on situations reality hasn't produced yet. That runs on top of Genie 3, DeepMind's world model. That's how seriously they take the pretend world. Now the translation, and it's brutal. Most agent startups evaluate by watching the agent run in production and hoping. If your agent acts on the real world, real inboxes, real repositories, real money, you need a place where it can act, fail, and be rerun against the counterfactual 1,000 times. Because if your only test environment is production, you don't have an eval. You have incidents. Moment 6. Count the AIS in your stack. 1. He says shipping one agent takes 3. And you've heard this loop before on this exact stage.
When you're dealing with a problem of that complexity, you can't just build a model and call it a day. You have to build an entire ecosystem. And then you also need a flywheel that powers it. Because to make this work at scale, you can't just build the agent and one AI, you need to build 3. You're building the agent, For us, that's the driver that drives the car. You also have the simulator, which is that virtual playground for the agent to learn in. And then you have the critic. And the critic is what rigorously evaluates and judges the performance of the agent and tells it how to improve. And the good news is that the fundamental reasoning and the generative capabilities of all three of those are shared, and that's why, in our case, they're based on the same foundation world model. Once you have these three pillars, you can create an incredibly powerful flywheel to accelerate your progress. So a deployment of your agent in the real world generates data. That data then grounds the simulator and makes it more realistic. The simulator generates harder edge cases for the critic to score and for the agent to learn from. So the agent gets smarter, gets deployed in the physical world, generates more data, and that powers the flywheel and accelerates progress.
The agent that acts, the simulator it learns in, the critic that judges every run and feeds the lesson back. Deployment generates data. Data grounds the simulator. The simulator generates harder edge cases. The critic scores them. The agent gets smarter. A flywheel. 2 weeks ago, Alexander Wang stood on this same stage and described agents plus the right eval loop outworking 100 engineers inside Meta. Different company, different domain, identical trinity. That is what a production AI operation looks like in 2026. And nearly every failed agent startup you've watched built the agent, skipped the playground, and never hired the judge. Last moment. Everything so far was the how. This is the what actually matters. The only thing in 49 minutes he calls a strategic moat. It is not the model.
But a flywheel, of course, will spin in any direction or in place. So in order to make it go in the direction you want, you need to guide it by metrics. And that brings us to the final lesson, that your model is really table stakes, but eval and metrics, that's your most important, that's your strategic mode. So build your eval before you build your technology. Build your eval and your metrics before you build your product. If you can't quantitatively define what good enough means, you're not really building a product, you're just iterating on your demo. So now trust becomes your ultimate business advantage, right? Your models can be leaked, algorithms can be replicated, but hundreds of millions of miles of fully autonomous operations in the real world, backed by evidence-grade evaluation and publicly audited proof, that is much, much more difficult to replicate.
Build your eval before you build your technology. Because if you can't quantitatively define what good enough means, you are not building a product. You are iterating on your demo. And that makes it 4 for 4 at Y Combinator this summer. The creator of Claude Code. Verification is the thing everyone gets wrong. Alexander Wang. The right eval is the difference between a swarm and an API bill. Jensen Huang. Systems thinking outlasts the code. And now the man who ships the most audited AI agent on Earth. Models leak, algorithms get replicated. But 200 million miles of evidence-grade evaluation cannot be copy-pasted. 4 operators, 4 frontier companies, 1 identical answer. At some point, it stops being a take and starts being the law. The 7 lessons. 1 breath each. A working demo is 1%. Waymo's took 18 months. The product took 15 years. Reliability is an exponential ladder of nines, and every rung costs 10x. Hype cycles exist because demos get 100 times easier while the tail barely moves. Count your nines before your demo views. Pick your technology for the nines you need, not the fastest early ramp. The simulator is a second AI. Production is not an eval. You're building 3 AIs, not 1. Agent, simulator, critic, spinning a flywheel. and the moat is the eval, because the model is table stakes. Two final clips before the free PDF. The first is what all those nines actually buy, his numbers from his published safety data. The second is where he says the next decade happens.
Achieve the strongly superhuman safety performance of the Waymo driver. This is a snapshot of the latest safety data we've released. Is based on over 220 million fully autonomous miles. And we're seeing there that in the areas where we operate, the Waymo driver is about 17 times better than human drivers when it comes to crashes that cause serious injury. And that really matters because today, somewhere in the world, every 26 seconds, someone loses their lives on a road to a crash event. And on the current scale, what that means is that Waymo is preventing a serious injury every 8 days. And this isn't just a metric on a dashboard. That means that someone's loved one got to walk through the front of the door at the end of the day, safe and unharmed. If you look at the broader landscape, the opportunity here is absolutely massive. Physical AI right now is where digital AI was a few years ago, and we have all of the right ingredients to go after it. We have the generative world models, we have the architectures, we have affordable compute and sensing, we have proven scaling laws, and we have a real product operating at scale. And the last decade of AI happened in the digital world. I think the next decade will also happen in the physical world. And for those of you who decide to build in this space, good luck, have fun, and remember who you're building for. Your mission and your customers, that's what matters. Otherwise, tech is just a science project. And at the end of the day, as exciting as exhilarating the tech is, nothing really beats the joy of making a difference in people's lives.
We condensed the whole playbook into the nines brief, a free PDF with every quote timestamped to the full talk, the 7 lessons as an agent builder's checklist, the how many nines does my product need worksheet, and every fact check receipt with sources. Comment the word nines on this video, and our assistant sends it over. Or grab it at hyperautomation.co/free/nines. Real talk. 90% of you watching haven't subscribed. On Facebook, subscribe is the supporter button. That is what keeps the lights on here. On YouTube, it's free and it tells the algorithm to send you more. Subscribe to support us. If you're just getting started with AI coding tools, the beginner guides are linked below. The complete Cloud Code guide, the Codex guide, the Cowork sales guide, and the Architect Prep Kit, step by step from zero. The Jensen Huang, Sam Altman, Alexander Wang, and Claude Code creator breakdowns from this same stage are linked below too. We are on YouTube, Facebook, and Instagram as Hyperautomation Labs. Same name everywhere. And this week, before you demo anything to anyone, write down how many nines it actually needs. That number decides everything else. See you in the next one.